Somewhere beyond Mars, 3I Atlas quietly broke formation. It didn't tumble or drift like a natural body nudged by solar wind or dust pressure. Instead, it steered subtly, deliberately, and with timing too perfect to dismiss. Inside NASA, the anomaly appeared for less than a minute before vanishing from the public feed, replaced by static and revised coordinates. But the agency kept a copy. The pattern embedded in the data wasn't noise. It was control. For the first time, space itself felt aware of us. When the Asteroid Terrestrial Impact Last Alert System, or ATLAS, flagged a faint, fast-moving object that the sun's gravity could not capture, astronomers realized they were witnessing only the third known interstellar visitor, following Oumuamua in 2017 and Borisov in 2019, both of which behaved like polite, uninvited guests passing through the solar system. But 3I Atlas, first detected on July 1, 2025, did not behave politely. Its arrival carried an energy that felt intentional. Its incoming velocity exceeded 42 kilometers per second, slicing across the ecliptic at an impossible angle no planet or gravitational encounter could have imparted. The initial orbit plotted in JPL's Horizons database traced a perfect hyperbolic trajectory, an elegant curve bending around the sun before exiting toward deep space. For months, every observatory from Hawaii to Chile confirmed its coordinates with mechanical precision. Then, approaching mid-October, the certainty began to crack. At 0:12 Universal Time, coordinated on October 21st, the independent analysis group Earth Exists reported that their telescope array had captured 3I Atlas several arcminutes away from its predicted position. Their measurement placed it at right ascension 13 hours, 47 minutes, and 54.3 seconds, and declination plus 0.8 degree 2116.2, while JPL's October 10th update predicted 13 hours, 46 minutes, and 57.5 seconds. The offset, 15.44 arcminutes, translated to a lateral displacement of roughly 1.1 million kilometers at a distance of $2.38, nearly 3 times the Earth-Moon distance. That shift alone should have been impossible. Interstellar objects follow gravity's script with merciless discipline. Even deviations of a few hundred kilometers trigger complete reevaluations. Yet Atlas's range readings remained perfect. No misidentification, no parallax, no atmospheric distortion. The telescopes were locked onto the correct target, but the target itself had shifted sideways in defiance of celestial mechanics. Analysts exhausted every conventional explanation: software desynchronization, clock drift, atmospheric scatter, but each test confirmed the same truth. The instruments were sound. Something out there was breaking the rules. Under normal circumstances, outdated ephemeris data causes predicted positions to lag. But Atlas didn't lag. It led. It was farther along its trajectory than any gravitational model allowed. To occupy that position, it needed a sideways force, a push perpendicular to its orbital vector. At interstellar scales, lateral movement of even a few kilometers per second requires staggering energy. For an icy nucleus the size of a small mountain, only 2 natural mechanisms exist: asymmetric outgassing or gravitational assist. Neither applied. Spectroscopic analysis showed consistent, gentle outgassing with no violent jets capable of producing thrust, and no bodies of sufficient mass were near enough to provide lateral gravitational acceleration. Yet the positional offset continued to widen, 0.23 arcminutes per hour by late October, an acceleration that defied every model. The equations described a comet. The sky showed intent. At first, scientists blamed the data, not the physics. The shift was too large, too uncomfortable. But star fields mapped cleanly against the Gaia DR3 grid. Atomic clocks synced flawlessly. Calibration frames checked out. The numbers kept repeating themselves, calm and unyielding. 3I Atlas was no longer where gravity expected it to be. That single fact cracked the foundation of orbital prediction. To achieve nearly 4 kilometers per second of sideways velocity, something had to be applying sustained, directed force. Not sublimation, not random jets, propulsion. Even stranger, the reflected light from the object showed subtle distortions, tiny flickers indicating organized magnetic fields. Simulations revealed that such patterns form only when ionized gas is being contained, not scattered. If the readings were accurate, Atlas wasn't simply moving deliberately, it was shaping the space around it. Comets typically brighten as they approach the sun, as heat wakes frozen volatiles and sunlight scatters through vapor and dust. But Atlas did the opposite. As its orbit pulled it closer, its magnitude dropped. The object grew fainter even though instruments confirmed increased outgassing. It should have been blazing, but instead it dimmed, absorbing or redirecting nearly a quarter of the light it should have reflected. Engineers familiar with plasma containment noted that the color signatures green, blue, faint pink were not random noise, but indicators of controlled ionization. Cyanogen glowing green, nickel ions glowing blue, hydrogen collisions producing pink. At first, this seemed chemical until the colors began appearing in clean geometric layers. Comets glow in chaotic clouds. Atlas displayed rings, sharp boundaries, and symmetrical divisions, like gas confined within invisible electromagnetic fields. High-resolution Chilean images reinforced the impossible geometry, while control stars appeared as perfect points and comparison comets showed natural diffuse halos. Atlas revealed crisp edges and color-segmented layers, an outer green halo of cyanogen, a blue interior ring of ionized nickel, and a bright white-yellow core fringed with a directional pink glow. These structures persisted across filters, nights, instruments, and continents. Spectrographs added another anomaly: hydrogen line oscillations in a perfect 4.3-second cycle. No known rotation period or Vince cycle matches that rhythm. The pattern was too precise, too controlled. Privately, researchers began using terms like coherent plasma zones and non-thermal emission structures, scientific euphemisms that admitted the truth without saying it. The nucleus behaved like a manufactured object wearing a comet's disguise. The strangeness deepened when NASA's LASCO Solar Telescope captured a brief cross-shaped burst of plasma on October 20th. The phenomenon flickered, vanished, then reappeared minutes later. Many dismissed it as a sensor ghost, until independent researcher David Sarita overlaid the LASCO frames with the ground-based images of Atlas. The alignment was uncanny. Same geometry, same orientation, same trajectory. Two different instruments, one watching in visible wavelengths, the other in coronal emissions, had captured the same structured object from opposite sides of the Sun hours after the LASCO event. The Earth was hit by a G4 geomagnetic storm triggered by X-class solar flares. Radio blackouts rippled across North America, satellites faltered, and the upper atmosphere flooded with electromagnetic interference powerful enough to distort long-range telescopes. The storm's timing matched the plasma fluctuations around Atlas almost perfectly. If the object had even a faint electromagnetic field, the solar impact would have agitated it. And that was exactly what the data suggested. As October neared its end, Atlas approached perihelion, the closest point to the Sun, scheduled for October 25th at 11:36 Universal Time Coordinated. From Earth's viewpoint, it would slip directly behind the Sun, hidden for days by blinding glare. For comets, this was routine. For Atlas, it felt tactical. Spacecraft often hide maneuvers during solar conjunction, using the Sun as cover. Perihelion is also the most energy-efficient moment to change trajectory, since the Sun's gravity multiplies any applied impulse. In the days leading up to perihelion, predictive models diverged wildly. One suggested the object would veer inward toward the solar limb. Another projected an outward drift toward Venus's orbital plane. The real object hovered somewhere between the possibilities, as if choosing its route in real time. Meanwhile, it continued to dim even as solar radiation increased. a contradiction to all known comet behavior. Then Atlas disappeared behind the sun. For 5 days, nothing emerged. No thermal echo, no reflected light, no infrared whisper. Yet observatories across Europe and Japan recorded something stranger than a signal. The absence itself behaved